Okay, so good day everyone. Today we're going to do January 2023, number 3, right? Which are usually transformation questions that we need to understand how to do. Now, let's just get right into it. The following diagram shows 3 quadrilaterals, P, Q, and R, on a square grid. Q and R are images of P after it underwent 2 different transformations. So P is your object and Q, R, and R are your images, okay? So let's go to the first part of the question. The first part of the question says, on the grid on page 8, that just means this, right? Draw the image of the quadrilateral P after a translation by vector 10 and -4 and label that image P. Now, first off, if we know anything about our vectors, we know that a 10 minus 4 just means the value on top is your x displacement and the value at the bottom is your y displacement. So there are 2 ways that we can do this question. I'll show you guys the 2 ways. The first way is that you take a coordinate, right, from P first before let's just write the coordinates of P, right, for the object. So this right here, this coordinate right here with the red dot is x is -7, y is 4, right? This is your first coordinate here. This one here, x is -6, y is 6. This coordinate right here, x is -7, y is 7, and this coordinate right here is x is -8 and y is 6. Right? So these are my coordinates for P. Now, the first method I am saying is you're going to take each coordinate and you're going to move it 10 places in a positive direction. If it's in a positive direction, we're heading to the positive numbers, right? So let us look at this. It is going to be, we're going to start at -7, 7. So we're going to go 10 units across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then 4 units. Because it's -4, we're going 4 units down. 1, 2, 3, 4. So my coordinate or after my translation of 10 minus 4 upon our -7, 7, right? My coordinate is now here, right? And then we do that for the other 3. So you're going to do it. We're going to start at -6, 6. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going down 1, 2, 3, 4. So my next one is going to go right here. Right, then we're going to look at -8, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going down 1, 2, 3, 4. So that is where my next coordinate is going to go right here. And then we're going to do this one here. 1, -7, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then going down 4. 1, 2, 3, 4. So we know that coordinate is right here. And then this would be, this where these four dots are, is image P. Now let us just connect these dots so we can actually see image P, right? So we know that it will be like this. Connect this coordinate and this coordinate. Right, and you connect this coordinate and this coordinate. Right, and then you connect this coordinate and this coordinate here. Right, and that would be image P. Now let's just say this was a larger number. You do not want to take too much of time to be moving 10 units and then minus 4 units down, right? So a next way that we can do this question is take each of these coordinates, right, turn them to column vectors, which would be x value on top, y value on the bottom, and add it to my translation. So what I mean by that is I'm going to have, right, object P, it is translating to 10 minus 4, translating, the next word to translating a slide, right, to image P. Now, object P, right, let us look at the coordinates. We have the coordinates from above, right? The first coordinate was minus 7, 7. Minus 7, 7 as a column vector would be minus 7 on top, 7 at the bottom, right? Then we're going to add our translation, which is 10 minus 4. Right, when we add it, it's going to be minus 7 plus 10, and then 7 minus 4, well, plus minus 4, right? And this will give me 3 on top and 3 at the bottom, which is also 3, 3 as a coordinate. My second coordinate is minus 6, 6. Change this to a column vector, minus 6 on top, 6 at the bottom, plus 10 minus 4. So it is going to be minus 6 plus 10 and 6 plus minus 4. So this is going to be minus 6 plus 10 is 4 and 6 plus minus 4 is 2. So my coordinate here would be 4, 2. Right, the next thing that we're going to do is minus 7, 4. Minus 7 on top, 4 at the bottom, right, plus 10 minus 4. So it's going to be minus 7 plus 10 and 4 plus minus 4, right, which is going to give you 3 on top, 0 at the bottom. So this is 3, 0. Right, and then the last coordinate is minus 8, 6. As a column vector is minus 8 on top, 6 at the bottom. You're going to add 10 and minus 4, right? Minus 8 plus 10, minus 8 plus 10, and 6 plus minus 4. Right, minus 8 plus 10 is 2, 6 minus 4 is 2. So my coordinate here is 2, 2. And after we get these coordinates, the 4 coordinates for image P, or P with a little one on top, right, we're going to plot these points. And if we plot the points, right, we're going to get these. So the first one was 3, 3, right? This coordinate is 3, 3. The next coordinate, let's check, is 4, 2. This coordinate right here is actually x is 4, y is 2. This one here is 3, 0. X is 3, y is 0. right? And then if we look at this, the last coordinate that we're supposed to get is 2, 2, which is this point right here. And then when we join all 4 points, you're going to get image P. So these are your 2 ways that you could have done a translation question, right? So A part 2 says reflection in the line y is equal to 0. This the image that you'll get would be image P2. Right, now we know, right, the line where y is equals to 0 is also on your x-axis. So I'm going to label it here, right, put this blue so that we can see, right? So this line here is y is equals to 0, and that is also your mirror line. I'm just going to put ML for mirror line, the blue line. Now, what you're going to do to get your image of P along your mirror line is you're going to count how many spaces there are from your coordinate, one of the coordinates to the mirror line. And then you're going to do the same thing going backwards after your mirror line. So let's count. From this coordinate minus 7 to 4 is 1, 2, 3, 4. So then you're going to go 1, 2, 3, 4. So you know your image is going to be this point, this coordinate right there. That would be your mirror image for minus 7, 4. Then you do the same thing for minus 6, 6. It's actually 6 spaces from the x-axis, or 6 spaces from your mirror line. So you're going to count 6 spaces, right? 1, 2, 3, 4, 5, 6. So it's going to be right here. You do the same thing. This is 7 spaces from your x-axis, so you're going to count 7 spaces. 1, 2, use the mouse. 1, 2, 3, 4, 5, 6, 7. So you know that your reflection for coordinates minus 7, 7 is this here. Then you do the same thing for minus 8, 6. It's 6 places away from your mirror line. So you're going to count 6. 1, 2, 3, 4, 5, 6. So it's going to be right here. Right, and this would be image P. The second image of P, sorry. So then let us just connect the line so we can actually see the image. So let's connect the lines. It's from here to here. And then from here to here. And then from here to here. And then again from here to here. Right? And that would be image P along your mirror line y is equals to 0. And that is the answer for part 2A. Now we're going to look at part B. Describe fully a single transformation that maps quadrilateral P onto quadrilateral Q. So if we were to compare quadrilateral P with quadrilateral Q, we can see that Q is actually bigger than P. So it is safe to say that this transformation here is known as an enlargement. Now, for enlargement, right, I'll put this in red. For an enlargement, there are 2 things you need to describe an enlargement. The first thing is you need your center of enlargement. And the second thing you need is your scale factor. Also known as K, which is equal to your object, it is equal to your image, length of your image, over object. So first off, let's find our scale factor. And how we're going to do that is we're going to take, you can take the length of anything in Q, right? I'll measure the length. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So my image is 9 units. So it's going to be K is equals to 9 divided by my object is 1, 2, 3 is 3 units. So K is 9 divided by 3, which is equals to 3. So my scale factor for P to Q is a scale factor of 3. So that just means that P is, not P, sorry. Q is 3 times the size of P, right? And then we want our center of enlargement. What we have to do is connect corresponding lines. So P and Q, they are corresponding lines. I'm going to connect this line and this line here. I'm going to go straight across, right? And then next line here, we'll take this bottom part here and connect it. Right, let's get the next line. We're going to take this line here and connect it to this bottom part here, and where these lines intersect would be my center of origin. So let me just show you a few other times. Then I'm going to go this line here and this coordinate here, and I'm going to connect the two, right, and just extend the line. And then let's do it the next time for this coordinate right here. This line here and this line here, connect the two. Alright, good. So now if we look at this, right, all of them intersect at this coordinate right here. Now you don't need to do all, I just showed all. If you have at least 2 intersecting, that is the coordinate. This coordinate here would be your center of enlargement, which is -10, 7. Right, so my center of enlargement is -10, 7. So how I would describe this is, let me just put this in Word, right? I would say that you can write out the whole word quadrilateral. I'm just putting QUAD, okay? Quad P maps onto quad Q by enlargement with a scale factor of 3 and a center of enlargement of -10, 7. And that right here would be how you describe this here. Describe a single transformation that maps quadrilateral P onto quadrilateral Q. This is your answer right here. Okay, so we have, this is part 2 of B. They said, describe fully a single transformation that maps quadrilateral P onto quadrilateral R. So I have a little part of the graph so that we can see it here, P and R. If we look at the orientation of R, right, if P is how it was before and R, we can clearly see that this is a rotation. Now, there are 3 things that you need to know for rotation. The first thing is you need to know your center of rotation. The second thing you need to know is the direction the rotation occurs. And the third thing you need to know is the degrees that the rotation occurs. So in this, you will need your protractor for sure. So first off, this is the first step, you're going to take two corresponding coordinates and join them. So I'm going to join P on P, that top value, and on R, that next top value. So let us put that as blue so we can distinguish the two. Then I'm going to draw a next line, this bottom part here and this bottom part here. I'm going to draw that red or pink, whatever color it is, right? So we're going to do this for these two lines. Then after that, you are going to find or use your ruler, right? Using your ruler is much easier than doing this on the whiteboard that I'm using. So what you're going to do is for these two lines, you're going to find out where is your halfway point. So you're going to find your halfway point for the red line and the halfway point for the blue line, right? I am just approximating, guys, but you will be using your what you call this thing? You'll be using your ruler. You measure the line to find the halfway point, you just divide by 2. So my halfway point for this red line is somewhere right here, right? And for the blue line, my halfway point is somewhere right here. Right? Now, after we found out our halfway point, you're going to use your protractor. Now, there are two ways to do this. I am showing you the protractor method because showing you the compass method is a little bit harder, right? Right, so I'm just using a different app so I can use the protractor here. We have this right here, right? The blue line and the red line, and then we have our protractor, right? This will tell us where 90 degrees is. So what you're going to do is if you look at your protractor, you see this T here, you're going to line it up where you think the middle of the line is. Right, let's line this up properly. Right here, right? And I am going to insert a line that shows me where my 90 degrees is at. So you see, we have the red line and 90 degrees is where you see 90 degrees. So we're going to take a line, use a ruler, and draw a line. Hold on, let me just draw this line a little bit better. I'm going to draw this line right here. Let's make it a little bit thicker because I don't think you guys would be able to see it properly. And I will use blue to denote that that is your perpendicular bisector or your perpendicular line to the red line. So this line here is perpendicular to my red line. And then you're going to do the same thing for this blue line. Right, let's just fix it a little bit better. Right? So then we're going to have this line and we're going to draw this image. Again, we're going to draw a line at your 90 degrees. It's just right here. It's going through that point. We're going to extend it because we want it to intersect with that first blue line. This blue line here. Right? Just make it red. First, let's make it bigger. Right? And then I will make it red. Okay. right? And this is how it would look. Let's just move this. And this coordinate where these two lines intersect, that is where the 90 degrees angle was made for the red line, this original red line and this original blue line, where these two lines intersect is known as your center of rotation. In this case, your center of rotation would be -4 and 2. Then after that, you are going to look at the direction that this is going. This is actually going in a anti-clockwise direction. If we're going from this coordinate to this coordinate here, from this coordinate where the blue lines and this coordinate here on P to R, we can actually see that this has been rotated in an anti-clockwise because it's going to the left-hand side, right? So we know it's going in an anti-clockwise direction. The next thing we're going to do is we are going to draw two corresponding lines to our center of origin. So we have this here, right? Let's make this green and make it a little bit bigger so we can see, right? And then we're going to draw a next corresponding line. So this line is corresponding with that first coordinate here. Right, so we're gonna let's put it on the screen. So these two points are on P and R are corresponding points, right? And we connected to our center of origin, which was -4, 2, and then we're gonna take a protractor and put it where these two intersect. Let's see if I can zoom up and you guys can see properly. All right, so we're seeing, you see I'm going to put this, right, so it can fit right there. We want it to fit. Now we can see that those two green lines make up a 90 degrees angle. So this object P and R has rotated 90 degrees in a anti-clockwise direction. All right, let's zoom out. Okay, so if we were to fill in everything, we know that our center of rotation was -4, 2. Let's put this. This was -4, 2. The next thing, the direction that it was rotated is an anti-clockwise direction. And number 3 degrees that rotated occurred. This rotation occurs at 90 degrees angle. So these are we found out the three things. So now we can say that quadrilateral P maps or mapped onto Q by rotation in an anti-clockwise direction 90 in an anti-clockwise direction 90 degrees about the center -4, 2, and that is how you would describe your rotation of object P or quadrilateral object P to quadrilateral image R. And that would be the end of January 2023, number 3.